Let's find the derivative using the quotient rule. I have a function that is equal to 2x squared plus 5 over the square root of x. The quotient rule states that if I'm looking at the derivative of a function divided by a function, that's going to be the derivative of the top times the bottom, subtract the top times the derivative of the bottom. So I have kind of a derivative, derivative, and original, sort of a mix match situation. And this is all over the denominator squared. For this particular problem, I have 2x squared plus 5 over the square root of x, and I'm trying to find the derivative of this thing. So we're going to start by taking the derivative of the top. So I'll have the derivative of 2x squared plus 5 times g of x. G of x is the square root of x. And I've got f of x. That's my top function, and I'm leaving it alone. 2x squared plus 5. I'm putting these things inside of parentheses so I make sure to distribute properly. And I'm looking at the derivative of the bottom. The bottom here is the square root of x. I'm going to write that suggestively as x to the 1/2 so I can see how to take the derivative a little bit better. As a reminder, x to the 1/2 is the same thing as the square root. So that's a nice way to kind of rewrite that. So we could use something like the power rule. And on the bottom, we have our denominator, square root of x, squared. Let's take some derivatives here. The derivative of 2x squared. The 2 drops down. 2 times 2 gives me 4. I have 4x. The power went down from 1, so 2 down to 1. The derivative of 5 is 0, so that first derivative is just 4x times that square root of x. Then I have minus 2x squared plus 5. The derivative of x to the 1/2, that 1/2 drops down, and I subtract 1 from the power. I'm using the power rule. On the bottom, I have the square root of x times the square root of x. The square root and the power cancel, leaving me with x in the denominator. So what I've done here, I had the derivative of the top and the derivative of the bottom. And I'm putting those inside of my quotient rule. Now, technically I'm done. I'm just going to make this a little bit nicer because 1/2 minus 1 gives me negative 1/2 for that power. So I have 4x root x minus 2x squared plus 5 times 1/2 x to the negative 1/2 power all over x. I found the derivative here. It's a messy looking derivative, but hey, it works. I'm wondering if I could have done this slightly different where I didn't have to use the quotient rule. So I actually want to show you another method for doing this same problem. Going back to an earlier tip, which is whenever possible, we should really try to simplify our derivatives or inside functions first before taking the derivative. So I could write that square root of x as the 1/2 power. So I have 2x over x to the 1/2 power, and I have 5 over x to the 1/2 power. When I am dividing, I subtract the powers, so I could rewrite this as the derivative of 2 times x to the 2 minus a half is giving me 1/2, or you could write that as 3 over 2. And I have 5x. If I'm subtracting this, that's the same thing as a negative exponent, so that's a negative 1/2 there. Taking the derivative of this, I drop the powers and I subtract 1 from the exponent, so I'm going to have 2 times 3/2 x to the, if it used to be 1/2 and I take away 1, I have half of 1/2 left over. Here I drop that -1/2 and I subtract 1 from the power. I was down -0.5. Now I'm down -1.5. I subtracted another 1. Combining together some of these things, 3 over 2 times 2, that just gives me 3x to the 1/2 power. A positive times a negative is going to make this minus 5 over 2x to the minus 3 over 2. While these two derivatives are equivalent, you may notice that when you simplify first, you do not have to use as many rules, and your final answer looks much, much cleaner. What's the takeaway here? Always simplify first. When you simplify first, it often allows you to skip some of the messier formulas like the product rule and the quotient rule that create a lot of different places that you have to fill in. So just a strategy to kind of watch out for. That was an example using the quotient rule and showing you that same answer if we simplified first. Let's check out some more examples together.